devices, then you're in the right place. So let's do that. So this is DIY IoT. LOL. We're going to create some connected devices today. I love devices. I love connecting them. We're in Detroit, so I figure RoboCop is our patron technological saint here. So we can pay homage and continue. My name is Jeremy Searls. I work for a company called Grainger. If you didn't know, we're the 10th largest e-tailer in the world, and I hate that word, and I wish that it didn't exist. But a lot of people don't know who we are. We sell industrial supplies. We are hiring, so if you're interested, hit me up. GitHub, Twitter, my email. I'm Jerry Searls. Before I give you my talk, I just want to kind of give a warning, so to speak. We're working with electricity. Their voltages, not high voltages, they're pretty low. There still is the inherent risk of, you might shock yourself if anyone's gotten bit by 110, like a numb for a second, you're fine, it's okay. You just, more so a spark, bring your house down. So with that in mind, I'm not an electrical engineer. I was a fireman, so I know a little bit about electrical fires, but I don't claim to be. But I mean, that's the beauty of the talk, though, is that I'm not an electrical engineer. I did not go to a computer science school. I have no degree in computer science, but just through basically learning, Googling information online, research I've done myself, visiting talks, anyone can do this. Anyone can build devices now. And that's the cool thing is that we are in this golden age of connected devices. So what you see before you is the top of the line, just released 25 years ago. This is the IBM X10 system, where you can control lights in your house with DAWs, right? No, that's pretty cool, yeah. Pretty slick, just with 30 or 40 keystrokes, you too can turn your light on and or off. So, no, we are really in this golden age. There's so many different, if you go on Amazon, it's unbelievable how many companies are sprouting up every day, touting their devices of controlling everything. Usually light switches, lights, connected bulbs, you name it, it's connected now. It's also a way to get hacked. But that's a whole other thing, that's not part of this. So exposing yourself with connected devices. So there's a device for almost everything, but there still are devices that kind of half do stuff, or there are situations in your life where a device doesn't really fill that gap. And 2 years ago, I was sitting in your seat. I was in a talk by the lovely Kristen Smith. She gave a talk on Particle. And Particle, for those that don't know, is a form of microcontroller. And sitting in that talk, I had messed around a little bit with Arduino. I've done work with what's called MicroPi, so it's Python that you can write to control servos. Really cool, but it still abstracts C code, so you're limited. And it wasn't a connected device. It's just if you use Arduinos before that don't have Wi-Fi, things like that. You write the code, the light flashes on and off. It's very fun. And you kind of put it in a drawer and forget about it. That's most people I know that buy Arduinos. They're sitting in drawers, so they're not really doing stuff. But I learned about Particle, and I was just blown away. Particle is kind of everything, your Internet of Things on a chip. So you have Wi-Fi, there's a version that uses 3G cell connection, you have analog pins, you have digital pins, you have your power, you have a bunch of stuff that I don't even know what it does yet, because I'm not that advanced. But I've done enough to realize that it's a really, really powerful tool, and it's about the size of a cockroach. It is tiny, 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 and they're cheap. You can get one ready to go for 20 bucks. This talk will focus on Particle just because it's the system I'm the biggest proponent of. They don't give me money, I wish they did, but they don't. So I have nothing to disclose, but they have an excellent IDE. It's a form of Atom. Atom is the text editor, and there's a open source version of it that you can just download and flash your hardware right over the air. Everything's over the air. You can plug it into USB. You can read from serial ports. You can integrate with a ton of services just through your Particle login, which is free. There's no subscription. Once you buy the device, you get access to everything, which is awesome. You're not having to host stuff. You're not having to write endpoints, things like that. Things just work. It's really cool. You can also just buy a Raspberry Pi and load their software on it, and you still have access to all this stuff. So even if you don't want to buy their hardware. This is just to look at when you buy it, you get access to their, you can just download it right now, their iOS app. So you have access to this is Tinker Toy, my little particle photon. I can connect it to if this and that, a bunch of services. And then this is what the IDE looks like. Really easy to use, super easy. So 2 years ago, I'm sitting in your seat and I'm thinking to myself, I can connect an Arduino to the cloud. I can make a connected device. I'm immediately thought to myself, I'm a remote worker, which means, of course, I do a lot of tasks around my home during the day while I work. So my office is up here, and often I'm doing laundry, which is sadly down there. So when my dryer finishes, I don't hear the buzzer. That's a problem. That's a problem. It's a problem to be solved for connected devices. I need to hear that dryer, and I'm not hearing it. This is my washer dryer. I keep telling my wife we'll buy a new one when they die. That was 10 years ago. They will not die. They're completely analog mechanical, and they're amazing, but the Maytag man is a very lonely man indeed. They're not connected in any way. So how would I do that though? How would I tell myself that my dryer's done? I could do it by vibration, right? So the machine itself vibrates as it performs a load. Well, it turns out it doesn't vibrate that much. Maytag did a good job. The cheap sensors didn't really pick up the vibration, so I couldn't do that. It uses power though, so I could sense when it's drawing more current. I could, but I didn't want to take apart any of the machine itself for, again, if we refer back to the fire hazard slide, I didn't want to actually alter the machine in any way. But it does make sound. So the machine makes sound, but so does the washing machine. So differentiating between the two was too difficult, and the sound sensors that are for Arduino, again, I use cheap sensors, and they're not that, they won't pick up that delicate noise. So what I decided on was temperature, right? So a dryer can predictably heat up and cool down over a period of a load. So that's what I chose. So I had my particle, I from your seat, bought it on Amazon and had it sent, and then I had to figure out how to read a temperature. So I bought a thermistor, which is a thermal resistor. Put them together. So thermistor has four pins on it. It has an analog pin, it has a digital pin, it has power, and it has ground. We will talk first about a digital pin. So I decided to use a digital pin. So there's a set screw right here, and when a certain temperature is reached, you can turn that set screw, and that will basically pop and give off a signal. It will give off a digital signal of 1. You will have a digital signal of 1 sent to the pin that you specify on your particle. So when we interpret a digital signal, we have two values. We have 0 or 1, on, off, true, false, high voltage, low voltage. Most Arduinos, if you're not familiar, if you haven't used them before, will work on some kind of a command loop, so they're always looping. So this loop is always running as my Arduino is running, and it's reading that sensor. So it's reading sensor values every couple thousand times a second. 0, 0, 0, 0, 0, oh, I got a 1. My temperature spiked. Once that happens, I can call a particle cloud variable that will then publish that event, which is really cool. And the code is that long, and I know when my dryer's running, and then when that variable changes, I publish an event that it's off, and I know my dryer's done. It's not, I just had to wire it up, right? So I got some telephone wire, which has power, ground, and data. Pulled it all back, threw a bunch of wires in there. Wife was super excited about it, but it's fine, we're still friends. And threw that in there. It's not the final version, it's kind of a fire trap, but just for testing purposes, ran a couple loads just to see what the temp was, got it calibrated, and boom, I was off and running. So I had a device, this is right through Particle's web interface. I was publishing events. I knew my temp switch was on. That would publish a text message that the dryer was started, and then once the temp switch was off, that would finish it up and say your dryer's done. And it worked. And it was really cool, and I was on a high. I was on a high. I was doing it. I'm IoT. Jerry, IoT. So this is the part of the talk where I say, what would you do? So a lot of you have probably used these devices before. They're probably sitting in drawers. They might not be, which kudos. But if they are, build something. I want you, the whole point of this talk is not to rebuild what I did or use this as an intro, but to think of what are problems that you could solve. So one of the cool things I saw was talking about fire hazards. Oh my god, electricity, if they had those poor fish. But feeding your fish with a device, that's pretty cool. Or if you're Aaron Patterson, knowing the position of your toilet seat is also very important and cool. You can ask him why. I'm sure he'll tell you. But think about a device. That's the whole point of this talk. Jog your memory. Think of things that you can do in your house to improve. So I'm riding this high. I have my connected laundry device, and we buy a new coffee machine. So we bought a grind and brew coffee machine, right? So I get to put beans in the top. I put water. All in one, I get freshly ground brewed coffee. Fantastic. One problem is the water. So the water in the tank, no matter what positional dial you tell it to grind coffee, it will just take all the water. So it has no idea how much water is in there. Every time you brew a carafe, it will use all the water. So you have to fill it each time you brew. You also have to fill it to the specific level that you're grinding. Not a great design, but this is what we had to work with, and I got really tired of filling it every morning. So I said, I can solve this. I got a guy. I can solve this. We can work this out. So my proposed solution was we have Alexa all over our home. So I'm going to build a connected device to fill my coffee maker, because I'm an insane person. And I will ask Alexa to fill my coffee maker by calling a fill water function. I'm going to make a cloud function called fill water. I'm going to open a water valve for a set period of time to distribute said water at set level, and you got a stew going on. You got coffee in your pot. It's just that easy. So I just need some hardware, right? So I have my particle, my photon was ready to go, and I just needed. By the way, Tim Allen, Detroit, everybody knows. He was arrested in my town, Kalamazoo, cocaine possession, but that's a whole other thing. Anyway, water flows from this solenoid. So I bought a solenoid on Amazon, $10, super cool. It even fits the fridge line. So most refrigerators now have ice makers, water distributors. They use 1/4-inch line normally. So this one I could just plug in 1/4-inch line. I teed off the back of the fridge. What's nice is the position that the valve is in. If there's no power, the valve stays closed. So if we had a power outage, I'm not going to flood my house, which goes back to safety. Safety third, everybody. Safety third. So it does run off 12 volts DC, which, what does that mean? Who knows? We'll find out. So it is a direct acting solenoid valve. So what the heck is that? Well, I had to look it up. So a solenoid valve works by adding power to an electromagnet, which pulls a plunger. When that plunger is pulled, it allows water to flow. When there's no water, a spring pushes that plunger back down, closes the valve, which is quite simple and elegant and works really well. My problem was, going back to 12 volts, I don't have enough power. So my particle only outputs 3.3 volts, and I need 12. But turns out this is a common problem. I did not know that. I don't know anything about electricity other than what I learned in high school. So I had to learn a lot more very quickly. So first, a quick refresher on what is voltage. So I really like this graphic. Comparing electricity to water is quite common, but if you had a barrel, the more water you have creates more pressure, which is your voltage. You drill a hole in the bottom, the size of that hole would be the resistance to flow, and then your amperage would be the rate of that flow, how fast water is coming out. So I did not have enough pressure to open my solenoid. I needed more pressure, I needed more voltage, excuse me. So I needed a switch of some sort. I needed to control high voltage with a low voltage signal. And in my head I was like, yeah, sure, but how do I do that? I have no idea. So I thankfully have a brother-in-law that knows a little bit about electricity, and I was like, dude, there has to be something that exists that can do that, right? And he's like, oh baby, is there. You're a simple boy. Simple boy. So to go down a rabbit hole, prepare yourselves, we're going through the looking glass. This is a vacuum tube. A vacuum tube is a way to control power. You can control one voltage with another voltage. You can add voltage and connect a circuit. So you have two positions. You have on or off. You have 0 or 1. This may sound familiar to those that are familiar with computer science and computers. Computers have 0 and 1. With one vacuum tube, you have 1 bit. We use bits in computers. That's pretty cool. If you have 8 vacuum tubes, you have a byte. If you have 8,000 tubes, you have a kilobyte. And now you have a computer. This is the reason computers were huge back in the day and took a ton of power and were highly unreliable because those tubes had to heat up. You had to wait for the tube. You had actual delays in that logic of on-off and sending that signal down, which is fascinating. And computers got a lot smaller because these little bad boys came out, solid-state transistors. And Steve Wozniak has called solid-state transistors the greatest invention of the 20th century, and it's the reason that you have an iPhone in your pocket that can do billions of those bytes because of these transistors. And they are now in your pocket the size of this. We're the nanotube level. So we've gone from tubes to nanotubes, which is insane. I mean, that's incredible. But we stand on the shoulders of giants, and I'm not here to bore you, but I think it's important to appreciate this fact. I think that's absolutely incredible. So how does a transistor work? So a transistor works, this little animation should look very similar to our solenoid. We are adding a voltage and we are getting flow. We're getting flow of electricity though instead of water, which is very cool. So by adding a small voltage, we can control another voltage. And you may be thinking to yourself, I thought I was gonna learn about coffee makers, and you'd be right. But this is important, and I think it's part of the process, right? So building these Arduinos, it's more than just a coffee maker and building a device. It's a path of learning and learning through projects and learning through design and learning through failure. And that's the goal, right? That's what we're all here for, is to learn. So I learned what a transistor is, and that's what I needed. I needed a transistor to control an electronic switch that would take electrons from my source and allow them to go to my drain. And drain, gate, and source, you are now familiar with, is the verbiage of transistors. We have an electronic gate, source, drain. Cool. So let's get some water flowing. So how do you do that? Well, we can write to our solenoid, so that we're writing to the pin that controls our transistor. We just tell it hi. So again, 0 or 1, we're sending a digital signal, sending at 3.3 volts. It's connecting a drain to a source, so we're now completing a circuit, and that is going to give power to our solenoid, allowing for the flow of water. And that's a lot to get water flowing. Let me tell you, when I hooked that thing up and called that, and that water, that's a good feeling right there. And that water starts flowing, that's a real good feeling. So that was it all wired up. It's not super pretty, but I got the job done. And so I want to keep it simple. So the project started with a solenoid. So, well, I have a solenoid, I can open it, I can distribute water. I can just write for those sleep, delay, just delay 10 seconds. We open the valve for 10 seconds, it distributes the water, we close the valve, done. Too easy. There are issues with that, turns out. I did not realize. Water, turns out, does not scale linearly. So if you open a valve for 10 seconds and get an amount of water, and then open that valve for 20 seconds, you do not get double the water. I did not know that. And I was even a fireman and took fluid dynamics and did not realize that, which is very sad. So I couldn't predictably couldn't predict the amount of fluid that was coming out, and that's a problem. So I needed to figure that out, and the way that I did that was I went on Amazon, of course. So why wouldn't I? So I went on Amazon, I got a water flow sensor. What the heck is a water flow sensor? And this is, again, the fun of Arduino. Now we get to learn. We learn through necessity. So a water flow sensor, I learned, is basically a turbine with a magnet. As water flows through, the turbine turns, and the magnet creates a pulse. That pulse is then measured right here. So every turn, we get a pulse. Turn, we get a pulse. The faster we turn, the more pulses we get, the more water is being distributed. So we have to count those pulses. We count those pulses with code using what's called an interrupt. Again, had no idea what these things were and had to learn them in order to get water into my coffee pot. Let's stay on track. So what is an interruption? What is an interrupt? So an interrupt, basically, every time that pulse is sensed as the pulse was falling right here, we're going to call a function. We're going to call a function called pulse counter, which is going to just increment our pulse by 1. So every time that pulse is falling, we're going to increment our count by 1. So we're going to count the number of pulses, which is really cool. And thankfully, we can attach and detach that interrupt. So if we go to our control loop, every second, we want to attach the interrupt, count our pulses, detach it, and then calculate the pulses per second. And we need the pulses per second because that's how we're going to figure out the flow of fluid into my coffee maker. Stay on target. So the pulse count is reset to 0. Once that's figured out, we attach the interrupt again. And that's a way we can keep a control loop, but also we can do calculations outside of that loop, which is really cool. So Alexa, did you hear me? I wanted some kind of a feedback device. So Alexa right now, you can give her commands, but she does not give you anything back. So I wanted feedback, so I decided to install an OLED with it as well. The library, I'm not going to go into it, but the library is basically built into Arduino now. You just import the library and you can just write right to the screen. You can draw to the screen. And so as things were happening, I was just writing strings to the screen, which is really handy to have that immediate feedback. So I started just wiring it up. So I had a solenoid, I had a water flow sensor, and I had a screen to tell when I was filling. So I could do some simple math and just create a little status bar that would draw as the water was being filled. But hang on a sec, you're filling all this water, what happens if the water won't stop filling? Says my wife. Please don't flood our house. So what if it won't stop filling? So that was the next problem, is I don't know. I should probably be able to sense if the water tank is full. How do I do that? Say water sensor. So I had to add a water sensor. So we've been using digital signals before. Now I'm going to use an analog signal. So an analog signal is going to give me a number, an integer, 0 to 1024. And as water comes in contact with this sensor, that integer is going to increase. And it's going to increase in a predictable way. And by testing, I could tell that it hits about, the second it touches water, it'll hit 10 or above. So as long as I could set 10 as my threshold, I'd know when the tank was full. And this is what we call cheap sensors a lot, and I didn't realize this going in, I just recently learned this, are noisy sensors. So a noisy sensor is, this sensor a lot of times will give me like just all kinds of readings that aren't right. That it's just cheap, and it's fine. But there's a way to counteract that called smoothing. So what I actually do is I take the best, or I take 10 measurements and I take the mean of that. And so that kind of smooths out those outliers and helps me get more predictable results. So I started smoothing my sensor, and it worked. And I was getting pretty predictable results. So now I have this control loop, right? So I interrupt my loop every second. With each loop I interrupt, I calculate the flow. So I get my pulses through my Hall effect of pulses per second. And then I can use an equation to figure out what that is in fluid volume. So now I've got my fluid volume per second, and I can tally that to an overall fill volume, and I call a fill function, so I allow mine to enter that loop. So if fill is true, if Alexa calls fill to true, once I'm in that loop, I can then open my solenoid. My solenoid's open, but every second, I'm going to be checking that water sensor. So if it's full, I'm going to know within a second, and we can set fill to false if it's full. Otherwise, I know the volume that's being filled, I know the volume that was requested, and once those are met, I can set fill to false and close my solenoid. And it's coming together. So with Particle, it's really cool. We can just create a cloud function. So I have my particle function of, I'm going to call it fill water. Just through the syntax of particle, instead of void, we actually return an integer. This is C++, by the way, for those that aren't familiar with it. We give it the argument of a string, and this is just part of the syntax for particle. So if it's called, if fill hasn't been called already, so you can't call it twice, just in case someone said 8 cups, 8 cups, 8 cups, 8 cups. I would only go once. We clear the screen, we set our requested cups to message, and we calculate ounces. So for some reason, my stupid coffee maker thinks that 5 ounces are in a cup. It's just really annoying, but it was fun to find out. Why is it not filling correctly? Oh, it's 5 ounces. So we just multiply by 5 to get our ounces, and we set fill to true, which allows us to enter that loop, that fill loop. So this is me, probably 2:30 in the morning on a Tuesday. testing out my water sensor, and as you can see, I dip it in a glass of water, and I get water tanks full. And that was, again, that's a good feeling. That's real good. It's a lot of fun. As you can tell, these are products of passion. I mean, I love working with this stuff. It's super fun, and it's so much fun to, I write code for a living as a developer, but to write code and then have it do something in the physical world is really special. It's really fun, it's really cool. So now I can just wire it up. So with my login through Particle, my login through this and that, and then my account with Amazon Alexa, I can integrate the three together. So I can create a trigger through a phrase of 2 cups of water. I can call my function of fill water, and I can give it an argument of 2. So the coffee maker only brews in multiples of 2 cups, 2, 4, 6, 8, 10, 12. So I just had to create 1 trigger per position. So Alexa fill 2 cups, fill 4 cups, fill 6 cups. And that's just altering that argument. We're keeping the same functions. I then created my non-3D printed enclosure. I believe it's pronounced by Glad. Just took some Velcroed it up. This is underneath my cabinet. Attached my water sensor right into the reservoir in the back of the coffee maker, and then just started testing, started calibrating, filling up that jug. To make it easier on myself, I did create a debug mode. So if I say Alexa trigger debug mode, I could get my current flow rate, the requested ounces, filled ounces, my counts per second, and my Hall effect sensor, and then whatever the water sensor was picking up.
Alexa, trigger 8 cups of water.
Sending that to if.
So I call Alexa trigger 8 cups. So we start pouring 8 cups of water. And you can see the water levels start to rise just a little bit. And this is the kind of scary part underneath that you can't really see normally, but you can because the camera's here. But there's my water flow sensor. There's my solenoid. There's just a safety valve, and then all that's wiring back to the control module. And so as the valve is opened, that water's flowing. We're checking our pulse count, checking that the water tank's not full, that flow command's still true, setting to true, setting to true, and we're drawing to this OLED. Once it's full, every time. Come on, stop. Come on. Oh, thank God. Thank God, stop. So we fill 8 cups. So this just stays on whatever it was last filled to, and then just a little timestamp to tell when it was filled. So pretty simple, super fun. TIL, today I learned. So interpreting digital and analog signals. So what's nice about this project is it encompasses a lot of concepts into one project. How a transistor works, which I think is as someone that's in code, I think is very important to know. And how to output a digital signal to activate the solenoid or electric motor, and then connecting hardware to cloud services, which is really, I think that's the kicker, the fun part of all these Arduinos, all these connected devices is getting them on board. So with that, I want to together, I mean, you can't really give a talk on Arduino and not bring an Arduino. I mean, I guess you could, but what's the point? So I built a small cat. This is my cat. It's Meneki Nico. It's a little. How does it work? So I wanted to build something to show off. I don't know if it's gonna work. It's connected to my phone's cell internet, so we'll see. But let's build it. Let's build it together. So how would we do that? So my cat has a nose. As you can see, it has a little, maybe over here, it has a little LED nose. And that nose has a digital input and a ground. That's it. So this is my module. And let's code it. So to code it, we have to define an LED. It's at position 1, pin 1. We have to set up the nose. So we define our LED. It is an output pin. And we create a particle function. This is really the beauty of it is you can just call particle function, and now once we flash this code, we have this function available to us. We have to obviously create the function. So again, using their syntax, we create an int function. We give it a string message. If the message is 0, let's write low. If the message is 1, let's write high. High meaning turn it on, 0 meaning turn it off. And that's it. That's our whole program. So using the IDE, you can compile it in the cloud, save it, and then flash it right to the device. Everything's over the air. Super cool, super convenient, really easy to do, and it's all just built in. So the second that it's flashed, we now have access to it in the web browser. So we're in the Particle web browser. We have our toggle LED function, and you can call it right within the web browser. You can give it an argument of 0 or 1. But we want to go a step further, so we want to connect it to if this and that, and ultimately to Alexa. So we choose our trigger, our Alexa trigger. We say a phrase. So Manikiniko is probably too hard to say for Alexa. So Money Cat Knows. Money Cat Knows should light up the LED nose, and then we're going to choose Particle. And once we choose Particle, I have access to not only my devices, but also the functions on those devices. So I can choose my toggle LED function, which immediately shows up once it's flashed, and I'll give it an input of 1, an argument of 1. And we'll see. Boy, I don't know if this is going to work, so we'll find out. Alexa, trigger Money Cat Knows.
Hi.
There's a cat. Nah, that's not gonna do what I want. Alright, anyway. So we call it the nose blinks. So I want to add a servo to it. So I want the cat to actually do something. So anyone, this overheads anyway?
Yeah.
Tom servo. So wrong servo, so we're gonna add an actual servo. So a servo takes a digital signal and it will set a position. So thankfully this is already built into our particle. We can just call servo and give it an object name. So we call it cat arm. So we have our setup. We attach it to the 0 pin, and we create a particle function of wave. So what is a wave? A wave is 2 articulations, right? A wave moves forward and it moves back. So let's create 2 functions. Let's create a forward function. So we have an integer with a position. The position being the position of the servo. The servo can go from 0 to 180 in any increment that you want. We don't want to go fully to 180, probably like 120. So we just create a for loop that will write to that servo to change the position. So we do cat arm.write. We give it a position, delay 20 milliseconds just to allow the motor to catch up. And that's it. So that's our forward, and then for backward, we do the opposite, right? We start at 120, and we go back in increments of 5, all the way back to 0. So now we have a wave. We have a forward, and we have a backward, and we can even give it an argument. So we can give an argument of the number of waves, how many times we want that process to happen, forward and backward. And we can pass that argument right through the particle IDE or through Alexa, through a function. So we can move the arm forward, move the arm backward. But let's do more. Let's smile and wave. So we're gonna smile and wave. We're gonna light up the nose, wave forward and backward the number of times that's been determined by the argument, and then turn off the nose. And same thing here. We can just wire it up through Alexa. Once it's flashed, once our code is flashed, that has those functions. Those functions become part of the cloud, and once they are cloud functions, they're available through if this and that. We give it a phrase. So the one kicker is you have to say Alexa trigger, and then give it the phrase. So we have to say Alexa trigger Money Cat Wave. We send it to particle, and we assign it our function. The function being smile wave. and give it an argument of arbitrarily, I think I put 3. So we want three waves every time it's called. And if it worked, that would be it. But it won't. I'll mess with it, maybe we'll get it working in a couple seconds. But before that, any questions? That's pretty much what I got. Very simple project. Wow, that was fast. Caleb.
Did you consider paying for a coffee maker that would just do the thing that you wanted to do?
That is an excellent question. That's lazy talk. Anybody can just buy a machine that does what you want. No, actually, I don't. Are there?
What was my question?
I'm sorry. His question was, could you just buy a machine that would do already what I wanted to do? I did look at some that we had a Keurig that would actually, would only brew what it was supposed to brew for that. So only the water tank. So you could just fill the water tank, but. No, this machine was the one that had the best reviews. I really liked the machine, and it was something that I was like, I can solve this with not that much money, but a lot of time, a lot of time, too much time. But if I hadn't, I wouldn't be here. So, hey-o. Anybody else? Anybody? Yeah.
What if the flow sensor didn't detect any water flowing?
What if it didn't detect water flowing? So if it did not detect anything, it would keep flowing. It would just keep going. It would just keep filling until it hit that emergency stop of the water sensor at the top. The only thing that the water flow sensor is really doing is tabulating flow. When the flow is met, obviously the solenoid is going to shut off. So that solenoid would just stay open, thinking I'm not flowing enough water, I'm not flowing anything, until it was just shut off by the water flow, by the actual water sensor detecting water. Anybody else? Nope. One? Yes?
What's your next IoT project?
Nice. Next IoT project is, I've been talking to a buddy that, I know they sell them online, and it's a product that does exist, but his dog is insane and has too much energy, and so we wanted to build a tennis ball launcher that he could load himself and shoot balls and tire himself out. We could just watch and laugh. That was pretty fun. That's probably the next one that's coming.
Takes too much time.
Hopefully not. But again, it'll be like, oh, but you need this sensor, you need a servo that can whatever. There you go. Yeah. Or even do a launcher. You could remotely launch the balls with a camera. I mean, that's the thing is, you could do anything. It's awesome. It's such a cool time to be in this realm, and all these parts, these servos, things like that, a lot of them are under $1 on eBay with shipping, which I don't understand how that works. I don't know the logic or the logistics of supply chain enough to understand how that works, but that water flow sensor I got was like 55 cents shipped. I don't work for Granger, so I probably should know this stuff. I really do not. I do not. So, anybody else? Is anybody gonna build something? Maybe. Built? What'd you build?
Got most of the way through my own version of Nest.
Ooh, nice.
Not AC, just heat.
Okay. And you're here to tell the tale, so apparently,
Didn't have to call any fire
No.
department.
didn't call fire department, they call you, so it's good. It's good, it's a win. Try to go with a W. Yeah.
This isn't really a question, but I have a friend who's doing a weather sensor thing, and I have a feeling he doesn't know about particle, and he has rolled his own of a whole bunch of these things. So I'm going to ruin his day by going home and saying, you should check this out.
Please,
It's
yeah.
super cool.
And that was a big
The weather
barrier.
integration is amazing.
Oh yeah, and that's the thing is that was a big barrier for me of going from MicroPython to something like this. I was like, I do not want to roll my own server and roll my own hosting, and I'm not that passionate. I'm pretty passionate, but not that passionate. So to have it all ready to go and just be able to troubleshoot and things like that on the fly is it's super cool. And the fact that it doesn't cost you money. Their Particle's goal is that you build a product and then want to scale that product. That's where they make their money. That's where the big bucks come in. Anybody else? Thanks for coming to my talk. I appreciate it.